So in this video, we're going to have a look at some upgrades and mods I've done to my Prusa Core 1. The first one that I've done is just got a new USB drive. So it's a SanDisk Ultra Fit, and they're very small. So it's just that little thing there, and it fits nicely on the Core 1. So compared to the one that you get stock, it's quite big. So it's a good upgrade. The next one I've done is I've got a Trianglelab's Silicone Carbide nozzle, because I've been printing some PCBWay, so it's good for abrasive filament. It's not high flow, so that's just something to keep in mind. So I think I've printed enough of my PCBWay, and I'll probably just switch back to the standard high flow nozzle, because I usually print PLA. The next thing that I've got is I've got this air quality meter. So it's by M5Stack. So I don't know if you can really, so it uses an e-ink display. It's also got some magnets on the back, so I usually just put it on the side, on this side. And it just shows the different levels of like the air quality. So I noticed that if you're printing some like certain stuff, like you'll notice the levels go up. So it'll be interesting to see how the advanced filtration system works as well. So that's just something, you know, that I like to sort of keep an eye on, just the air quality. The next thing we've got is I've also upgraded the bushings. So I don't know if you can see it, but the bearings. So I've replaced the standard bearings with these Vesconite bushings, Vesconite 3D printer bushings. So I've used these in the past. I've used the 8mm ones in my Prusa MK3S, and I've had it for 2 years and they've worked really well. They're super quiet, low maintenance, so I don't have to lubricate it at all. All I do is just wipe the rails every now and then if they get a bit dusty. So these are the 10mm ones. So with the 10mm ones, the stock ones actually come in pressed. So this is from this one, and I've had to press it out with like a vise. And use some sort of 3D printed parts to help push it out, and then also press the new bushings into place. So yeah, it's a little bit of work for these ones, for the linear rails, but I think they should be a good improvement anyway, but we'll wait and see once I've put my printer together. So yeah, let's just quick look at it. I might just put one on. So this is the 8mm. So yeah, it's super quiet, like you can't really hear them at all. And they move around pretty well. So they slide pretty well. And then we've got the linear rails. So yeah, super quiet compared to stock bearing ones. So I put those in, and then on the bed, same thing. I've already got them installed. So once I put my kit together, I'll be able to test it and see how they go. So let's just look at the bearings. The bushing, sorry. Have a quick close-up look. So they're self-aligning, so what that means is the bushing material actually can swivel and move a bit, and align itself with the other side as well. So yeah, we'll wait and see how they go. So I just wanted to say a quick thank you to the sponsor of this video, PCBWay. If you want to take your projects to the next level, they offer a number of different services, from manufacturing PCB boards, CNC machining, 3D printing, sheet metal fabrication, and injection molding. They also have a module store where you can get tools and other useful modules. So they've kindly sent me this to help build my Core 1. So I've got 2 screwdriver sets. I've got the MiniWare ES15S motion control, so it's just an electric screwdriver. So it was really helpful. So I've got the Torx bit there for the all the bits I use for the core 1. So it's just a matter of turning it. So yeah, you can set the different torque levels. So I'd use this just to pretty much screw it in first, and then I'd use the Allen key to tighten it up to the specs that I wanted to. So that's been really useful, and it's actually really quiet. So I think the ES15, which is the older model, it was quite noisy. So it had like a bit of a gearbox sound to it, whereas this one's really silent. So I don't know if the S stands for silent, but this one is definitely more silent than the previous version. So that's been really useful. They also sent me this precision screwdriver set. So it's got a lot of different bits in there, nice and long. So they've got nice long bits, and this is just the screwdriver bit. So it uses a sort of like a proprietary bit. Goes in, if I can put it in. So it's got a nice hold. And then another feature for it is if you pull the collar down, you can extend it out. And it's got a little swivel thing here at the back as well, so it's quite nice to use. So just push it down. Yep. So yeah, if you need any of these services or tools or modules, I'd highly recommend you check them out. So I've used their services before, and I've been really happy with the quality of the products and the service they've provided. And we'll get back to the video. And they're working pretty well. So I haven't done that many hours on it, so I can't give you a definitive answer, but I've had them in my MK3S before, and they've worked well. So I might just see if I can. It's not really a good test, I think, but I'll just put the Z up. So yeah, it's quite quiet. I don't know how quiet or how loud the bearings are. So because I've replaced these pretty much straight away, so I have nothing to sort of compare to. That's it there. The next thing I've done is I've printed this. So I've just redesigned the stock rear bed stop. So this one's just got it's got a bearing in it, press fit. So it helps with I don't know if you can see it, but I've got it there. So it helps so the rear rod is stable. So also I've got a spool holder. So it's got a bearing inside it. So it's got two bearings. So take it off. And you just chuck it on. It's a bit hard doing it one-handed. A little bit hard one-handed, but that's it there. So it's a bit smoother, but yeah, it's I've adjusted it when I put it in. I adjust the nut, so I give it a little bit more resistance, so it doesn't spin too freely. So it's worked really well. I don't know if you can see there, but I've got a little, I'll just show it here. So I've 3D printed this, so it's just a cover for the hole that is usually there. On the back of it, I just put a recess, some magnets, and I've put an LED in, and I've connected it to the filament sensor. So when there's no filament, it just shows a red LED light, just a sort of indicator. And if I put filament in, you can see it'll turn off. So yeah, I'll put the STL files up, so it's available if you want to do the same thing. What else do I have? So I've got the next thing I've done is I've done a little external Wi-Fi mod. So with the Wi-Fi board, I've just reworked the cover, and then I've soldered in a IPEX connector, and I've put a external Wi-Fi. So if I put this in the garage or something, far away from the actual router, it's going to help it pick up a little bit better signal. This is the external antenna that I've done for the Wi-Fi board. I've just essentially modified the Wi-Fi board. I've cut the trace for the antenna in 2 spots, got there and just one underneath the connector there, and I've soldered it on. Then I've just remixed the casing. So it's pretty much the same thing. I've just put a spot for the SMA connector. So it just goes up on the top. And then I can get the Wi-Fi board, connect the jumper cable for the accelerometer, and it just goes in like normal. So I'll connect the antenna up. And then it can just go in on the top. So it's in line with the jumper cable. So that goes through the casing, and it will sort of squeeze in like that and goes in, and it sits nice and flush. Everything else is normal. And just connect the antenna up. So on the core one, it sits right in between the PSU and then the electronics box. And the next thing I've done is, if you can see it, you can see the switch there. So we just had a switch, so I've had just wired the switch into the actual normal light, the chamber light. So I've just got some wires running down the bottom, and just essentially just cut the wire and put a switch in. And on the other side, I've actually got another switch. So this one will switch another set of lights. So I've put another row of LEDs up here, so I can change which one I want to use. I can use both, just give it a different visual perspective, or I can turn them both off. So that's that one. Yeah, so it's just a rework of the base of the, what do you call it, the rear mount for the display. And the last mod that I've done is I've updated or upgraded the lights in the status bar. So they're just usually 5 standard RGB lights, so they're non-addressable. So I've put addressable ones in, and I've made it go all the way across. So I've replaced 5 with 27, and these are addressable. So this is a look at the LEDs that I put on. So the stock bed has this LED strip. It's got 5 LEDs, and they're just RGB, non-addressable. What I've replaced it with is this NeoPixel LED strip. So it's got a total of 27. So it should give the full range on the light diffuser. So it'll go the whole way. I've also double-sided taped the light diffuser on, because I think the stock one has this heat shrink on both sides that helps to sort of push the light diffuser against the cover. On this one it's a bit thinner, so it didn't work, so I just double-sided taped on to give it a nice hold. So I'll just put it back together. So hopefully I'll be running this off using an Arduino Nano. I've just got to work out how to get the stock outputs and convert it into the RGB, the NeoPixel signals. The other thing I did was with the extruder, I wanted to put some lights on it as well. So this is the backing plate, and I've just got a RGB ring. So it's a NeoPixel RGB ring, which is addressable as well. So what's going to do is send the signal to this one, and I'll go through the strip, and then I'll get the data out, and I'll put that as the data in for this one. Just got a 3D printed cover, which just goes in. So I'll glue that in once I put it all together. And then it just sort of press fits against this like a nut. And that's how it's going to sit. And I might just put a couple screws on as well. And then yeah, you'll have the fan on top of this as well. So turn the bed around. Try the best view. Let's plug it in first. So this is just what I'm sort of running it off at the moment. So we get some power. So yeah, gives it a nice look to it. And if I press this button as well, I can change it to like a green tracing. But yeah, hopefully I can get this all working on the actual core one once I set it up. So this is the RGB control board I've created. So we've got an Arduino Nano. We've got 3 octocouplers, which acts as a switch. And we've got some resistors. This is the input. So the input will be, there's a common positive, which goes to the octocouplers, so they're all connected. And then you've got a red, green, blue. So one of these is red, and one's green, and one's for blue. So when there's a negative, when the 3D printer supplies the negative, it will trigger this, and this acts as a switch. So it essentially just acts as like a button press. So when this one's got the power, it'll connect, for example, ground to D3, and then Arduino knows that red's been activated, and then I've got a program in here to say if red is triggered, you'll do so and so, and it'll come out through the output. I'll also put a USB-C here, so this will get power from the extension board, and then I've put this one here, so when I've connected the buddy cam, can go and get the power from this port. It's just like that. And this is what it looks on the back. And I'll just put 2 magnets on so I can just stick them onto the 3D printer with all the other cables. And essentially, so it's just so I can, you know, easily put it in and out if I want to change some of the programs for the lights. When it's in idle, I've just made it do a like a dim blue, and I've also got some addressable RGB lights in the extruder as well. So it's just at the back. I don't know if you can see it. There. So if I go back to, so this will change lights depending on what the normal status lights will show. So if I go print, and I'll get RGB, like a rainbow RGB. So when it's printing, it will show that. So it looks quite nice. And then when it's finished, it'll just go a solid green. And I've also disabled the LEDs in the display as well. So it had a little bit of light bleeding onto the, like, sort of the table, which I didn't like, so I've just sort of gone in there and desoldered the LEDs. I mean, if you don't like that, you can also just go in there, just like put some tape over it as well. So just cancel that. And yeah, see, like when I've cancelled it, it's just gone back to the idle blue. So I can program it to whatever color I want. So hopefully this video has been helpful, and you've picked up maybe some things that you want to do to your Core 1. Please like and subscribe, and I'll see you next time.